Hey class, so today we're going to describe and graph transformations of absolute value functions. So by this point we've already been graphing using the equation. We've also been describing the transformations, and so now we're going to actually use those transformations to get a quick sketch of what our absolute value functions are actually going to look like, okay? So we have these steps here. And I want to follow these steps that we see here 1 through 4 as far as identifying the transformations, right? And so it says here, identify the transformations in the vertex. So step 1 says, identify any negatives. Well, I don't have any negatives, so there's no reflection. Cool. Then I want to identify a coefficient. Well, I got this coefficient here, so that means a vertical stretch by 2. And so we got that. The next thing is identify any addition or subtraction inside the absolute value. So inside we have this -3. So when we have a -3, remember we see it as the opposite. So we're going to see it as 3 units to the right. Okay, we got that. And the last one says identify any addition or subtraction after the absolute value. Well, I've got this +1. So we're going to go 1 unit up, or 1 up unit. It should be 1 unit up, sorry. So 1 unit up. So we identified the transformations. Now to get the vertex. Oh, okay. So let's talk about that vertex. At that vertex, remember, we learned that we take what's inside the absolute value, okay, which is at x minus 3, and we set that equal to 0. So then when we add 3 to both sides, we get x equals 3, right? So, and I'm going to write this off to the side. I'm going to say vertex equals 3. And to get my y value, you can substitute that 3 back into the function, or you can simply look at what is being added or subtracted. In this case, we have that 1. So now we have everything that we need to actually do a quick sketch of this. I know my vertex, so I'm going to come to 3, 1, and I'm going to put that point. And so let's look at everything that's happened. We have our vertex, which satisfies the 3 units to the right, so we're good with that. We have our 1 unit up, we're good with that. So now when we draw our shape of our absolute value, we know that we're going to be going up because we don't have a reflection. There's no negative. So we know we're going to go up. And it's going to be a little skinnier than the traditional parent function because we do have that vertical stretch. And this is a nice rough sketch of your absolute value for this function. And this is just using those transformations. So you don't need a calculator or Desmos or anything to actually be able to start visualizing what these absolute value functions are going to look like. Okay? Very cool. Let's do another one because I felt like this one was a little fast. Let's do another one. So let's look at this function here. Step 1 says identify any negatives. Ah, I see a negative here. So that means I'm going to have some type of reflection, which means our absolute value is going to be going down. Okay, and we got that. The next bit says identify a coefficient before the absolute value. Well, I got that 3, so we're going to have a vertical stretch by 3. Okay. The next step says identify any addition or subtraction in the absolute value. Well, I have that +4. So remember, it's always the opposite of that. So we're going to see, or we're going to go 4 units, okay, left. Okay. So 4 units to the left. And then the last bit says identify any addition or subtraction after the absolute value. Well, when I look after the absolute value, I don't see anything there. So that means that we have it's essentially a +0. That's important to know, okay? Because that's going to be important when we look at our vertex. So now let's look at our vertex. So for our vertex, we're going to set what's inside the absolute value equal to 0. So we have x plus 4 equals 0. When we isolate our x, we get x equals negative 4. So our vertex value, okay, my x value will be negative 4, and my y value, if you take that negative 4 and you plug it back into this absolute value, you will get that value. Okay, and you're actually going to get 0, or you could identify that there is no shift up or down. It's a plus 0, so your y value will be 0. So when we graph this, we'll go to negative 4, 0, and there's our vertex. So let's start checking off what we've satisfied so far. Well, we haven't done anything with a reflection yet. Our vertical stretch, we'll do that in a little bit. Well, we did go 4 units to the left, and we didn't go up or down. We stayed at 0, so we're good. So now with the reflection, we know that we have to go down because it's a reflection with a vertical stretch of 3. So that means that we're going to have an even skinnier version of our parent function than we would normally see. And so we'd get something like this. This satisfies the reflection, and this satisfies the vertical stretch. We stretched it out, making it skinnier. Alright guys, so hopefully this video helps with this lesson. We will be doing more practice with this tomorrow. So be ready for that. I look forward to seeing you all. Please be sure to answer the check for understanding questions in your team's assignment, and have a good night. Bye guys.